And now how we will go with estimation model, because today we will be covering till random effect and to know whether we are going to use fixed effect or random. But before, we cannot just have a data and we'll say, okay, now we want to run random effect and the fixed effect. We just cannot do like this. So before that also, we will use pooled OLS method. Then we will go with the fixed effect method. And then we will use the random effect one. I think the second number is wrongly written. Please exclude that. We will use pooled OLS and then we will go with the fixed effect model. Okay. Now you will say that why we are using pooled OLS, that's fine. That's a regression is being run. And why we have to then go to the fixed effect model, and how would we know that we have to use fixed effect or the simple OLS? So is there anyone who has done XT test? Okay.
Like the NG multiply.
Okay. Anybody else? Okay. So we have pooled OLS. So OLS is a simple regression, ordinary least square method that we are going to use and to get our information. But then when we use OLS, as we are talking about the panel data, we have to be very cautious about the heterogeneity thing, right? And also, it's a big data. You just put it in your software and you got the regression result, and everything software will do. They will not say no to anything. Whether it is correct or not, that's you have to decide. Now, your role is more important. You will run the analysis and you will see whether the test will be run, and you will try to use it. Like, should I use this? Then you will go on to use fixed effect, and then you will compare whether should I go this or not. The simplest thing that we are going to use when we are going to run is that we are going to use pooled OLS. Then we are going to run a test to check whether the result of pooled OLS are good enough or not. If the result tells us, yeah, the results are good or there is no problem, then fine, we'll go with it. Okay? But when we are running the pooled OLS, we specifically, if we have the marker, yeah. So we have this equation like this. Right? This simple equation that we used in our panel data once. Now this is your dependent variable, right? And these are your independent variables. I've collected a data of any firm or any XYZ country, and you have different variables. Do you think that there will be no problem in this? When you collected the data, fine. There are some things that will create problem that you just left it and you just could not measure it. That will give you a problem, right? So if you just pick a data and do the analysis, this data will give you results. There is no problem. They will give you results. They will never say no to you when they are getting it. But then you're like, you have to decide, okay, now we can have a problem of opportunity here. Or my result can be inconsistent, or my result can be bad. Now let me go on to use fixed effect model and let me see whether I can use fixed effect model, and they will give you result for fixed effect as well. But when you're running a fixed effect model, under that we have LSDV, within group, and first difference. Now, if you remember, when Sir was saying, we were writing some equations like YIT minus 1, and then we were demeaning the values and taking the mean of it, subtracting it, and then finding the values. The same thing we are going to do practically today. Okay, what Sir said, we are going to do practically. Now we are going to use least square dummy variable. Now, suppose I have a small data, like suppose I have only 2 independent variables, 1 dependent variable, and we have data for 10 firms. For that, I can easily introduce a dummy. You know what is a dummy? I'm considering for every. Now see, suppose you have collected a data of 10 firms over a period of time. Okay? That 10 firms on the surface root looks the same. There is no problem. But when you run an analysis, when you actually want to go through it and more deeper into that, you will find that there will be some things that are different for each firm. We are running an analysis. We got a fixed effect model and we have the intercept value. Now that intercept is same for all the firms. Is it true? Because we had the data, we just put it in Fedder. Now, if you introduce a dummy least square model, you will see you will have different intercept. For each firm, you will have a different. When for each firm, you will have a different intercept, you will see that the values are different. Then how can we get this value here? How can we assume that it is same? Here comes a little problem. Now, when we have short data, it is easy to introduce dummy and do the analysis and find out the result. Okay, fine, we will be able to do it. But if you have a larger data set, introducing a dummy becomes a problem, right? You cannot just go on to introduce the dummies. When we run the regression analysis, we will see that whatever value we will get when we run the least square model and when we just run the fixed effect model, the independent values will be same. It will not be different. We'll run it and we will check it. It will be almost same. Not much difference will be there. But we will avoid using, most of the papers even don't use, they avoid using it because when you have a larger data set, it creates a problem. And you cannot just, manage it properly. And also, when we talk about within group, what we are going to do it, we have the data available to us. Suppose we have a data for 10 firms, we are going to demean the values and using that calculations, we are going to find the values. And then you will find that when we demean the value and run the regression on that, the intercept value will come out to be 0. Analysis will show that the value will be 0. Now, when the intercept value comes out to be 0, you will see there is not much difference among the two tests. Therefore, we moved on to the fixed effect actual model that we are going to. After you save the results of the fixed effect model, we will go on to use the random effect model. Run both the tests, store the values, and we'll try to find out which model is better and which is not. This is what we are going to do in today's practice session. So I have given the Excel. Can you please open it and we will do it together.
WhatsApp. Got the data on WhatsApp. My password. This is mobile data, na Ashish sir. This is mobile data. The internet. Okay.
So this is what your data will look like. Please open it. And the file that I've given, you can use that in the class now for the reference. We will do it together. And then on your
One caution, please put off your Wi-Fi once you open the data. Hold on.
No. You take it for each thing.
Wi-Fi off करने के लिए बोलो.
And then when you run
Cool. Data download करने के बाद Wi-Fi off.
हाँ अभी Wi-Fi connect नहीं हुआ.
Connect नहीं हो रहा. Good.
Wi-Fi code
कहाँ से download कर रहे हो? With your own.
Okay.
ITM. Sir, what is password? Some $. Same password.
In password.
$. 1, 2, 3, I think. Let's see it is working. Same password, sir.
Yeah. You will how to decide that.
Connected, na?
Of voltage. If you are using EDU,
हाँ, करिए ना, कोई बात नहीं, हाँ, हाँ.
value, the p value, it is 0.05. And if the value is less than that, that means okay, fine. It is
This is the password.
This is profile.
GITAM guess.
GITAM.
A new window is popping up.
Connected.
the then you run the
Already I got connection.
Station मैंने किधर है data?
Please everybody open it.
मैं वर्क करने जा रही हूँ ना.
Haven't downloaded.
आप वहाँ जाइए मैडम.
User remove password.
ये दो ना.
If anybody downloads, please circulate for the pen drive.
Let us see.
User ID, password, this will not work. Give me pen drive.
You're having so many folders on your desktop.
Whether you got now?
It will become very slow.
So should I? Done.
It's not getting.
I am trying to give by this pen drive. Data.
GITAM guest लिया connected.
आपको मिला?
You know, those who are new to startup,
Have you? Yes or no? ये नंदी. Yes.
कहाँ पर है? हाँ. हाँ,
And it is also circulated on mail. Okay. If you download it from the email, that's fine. Completed. Madam, give me. Madam, you can say take rest.
no. So those who have this data open, we can go to file here. And from here, you can go to import.
Don't click on it.
Here you can click on Excel, browse, just ejecting.
Oh, editing is done. Data.
And here you have stored your Excel. You can just click on that and open it. Now, please, while you're putting it, please click on import first row as variable names. Okay. Then it's done. I think everybody imported the data.
Data.
Ishan मुझको.
Can you repeat once again?
Data.
Yeah. So you go to file.
Madam, please wait a minute.
Okay. Sir, I'll
Inclusive teaching.
okay.
Is passing this way. Pendrive is data.
इसको भी दो नहीं तो मैं PRS में हाथ रखूंगा.
Pay the feed.
हाँ.
Fee.
हाँ.
Pendrive is started.
बस तुम्हारा फंड्स दूंगी ना. देखना. तुम्हारा फीस.
Workshop data, madam. This is.
फंड सैंक्शन करने के लिए साइन ही नहीं करोगे देखिए. कहते फीस पे नहीं किया मैं बोली फंड्स का सिग्नेचर करना पड़ेगा ना, नहीं करूंगी।
Just copy.
And the first row
कुछ
should
देना
be
पड़ता है।
Yes.
मैडम वो बिहार में चलता है ये करना।
Yeah.
यहाँ भी है।
Import variables. Yes. Click on this. Yes.
स्टेटा में ये सब
So everything. Yeah. Click on. No, no, not this. No. We are not going to use import of data as strings, not Java.
स्टेटा में मुझको भी
So you have your data. Now everybody has their data.
I'll do it. Rest of my
Go to imports. You can go to imports. Click on Excel. We have the Excel file. Click on that. Select the file that you have to use. It can be your data or anything, but today we'll go with this data. That will be a little easier for you to. When you click on import first row as variable, most of the time when you work on the panel data and you have just set your panel data, you have to click on the same. And then you click on OK. So if there are already any data there, like what we have, I already have data here, which is reflected on this side. So they are asking me that should, if you continue, this data will be removed and new data will become. That's fair enough. No problem. Will not have any problem. We click on yes. Right? Now from here, you can even go to data and go to data editor from there.
Data.
And data editor edit.
Everybody had data?
See your data here. Can you see the data file on the data editor? Right? What data we have there, we have put here also. Okay. Now,
Everybody on the same phase, madam?
yeah, most of the thing I have already done on the sheet, but while we are, having it, you try doing it again. Okay. And just give a different name to a variable or the other things that you can do. Now, if sometimes you're working and you may lose what you have found out your result, you can save your file here. You can click on log and here you can click on begin. Right? They will ask you for a name. You can give your name or the work that you are doing. And from there on, you can start and your file will be saved there. So all the commands, you can have it later also. So suppose I want to save it on desktop with my name on worksheet. Worksheet and I click on save. So now what will happen that whatever I write here, whatever command I give, later at the end, it will be saved. I'll close it once we finish with our analysis. So every command that you're giving is saved with you, the laptop, and even results will be available, or whatever results you get, that will be available to you. Is it okay?
It was log, not SMCL, as far as I know.
SMCL.
We have to save it as log, bracket log.
Okay, you can do it like that. There's no problem. But here, what I've saved is when I open it later, it will be open in stata. So that is. Wait.
You use file DTA file and actually data in the Excel format.
Yes, data. No, sir, data is in the Excel format. That is fine. But here I am trying to save whatever work I do, it gets saved here.
Data is how data is important?
Not data. Data is not saved. Only what suppose I'm setting a data that later on you can see.
Okay, okay.
Data will not be saved. Data you have in Excel, it will remain in Excel. Nothing will happen to your data. Suppose I set my panel data. Before we start working, I have to set a panel data for the analysis. So that command you don't forget again and again. You can use when you're running any other analysis also. Suppose today you have learned how to do random effect and fixed effect model. Tomorrow you want to go and use it for your thesis. Your variables will be different, things will be different. And Stata is very command sensitive. So if instead of writing a small letter, you write a capital letter, it won't take. Okay, so it's very spaced and all that sensitivity is there. So once you have to do nothing, just copy and put your variables and that work is done. So you don't have to remember all the things again and again. Clear?
Start from the beginning.
Okay. I start.
Here, start Stata, open, and then start.
Okay. So we have this data. What we are going to do is we are now going to download our data. We go to files. Thing.
Madam, there is this.
Yeah.
Yeah.
We'll go slow. We have the whole time and we'll go with it. Go to file and from file go to import. File
Import.
is in Excel. We click on Excel. We click on browse.
Just now.
And my file is saved in desktop workshop folder. So I go there, I click on the workshop folder. Then you open it. And then you click on import first row as variable names.
Okay.
Then you click on open. Right? Clear?
Everybody done?
That ma'am. So suppose ma'am, if you want to see your data, you can just click on data and go to data editor. You will see here your data. Now we already have our panel data with us. This, if you look at the data, this data looks like a panel data, which I have already shown you in the initial slides. So the first thing that we are going to do is we are going to set our panel data. If I just run any analysis, I cannot do it. I have to tell my software that we are working on panel data and the software will tell us that whether it is a balanced or unbalanced data, right? So the command that we are going to write here is, it is xt set PID and here. Just click on this. It is set and we have panel data CID strongly balanced time from 2001 to 2020 and then we have 1 unit data. That's. Is it clear?
Everybody got it?
How to go back to this page?
You want to
This.
See.
from the bottom, you can easily go back now.
To ensure that whether a data is balanced or unbalanced.
And also you need to tell software this is a panel data, otherwise software doesn't know. So even if you put your time series data in data, you have to set data. Then another command is there, xt set, set. PSS, yes.
Yes, that is.
S.
Set.
Okay, okay.
Much for the container.
So you need to put that value and then they will tell you, the software will get to know that, okay, now we are working on the time series data and we'll start working. Now we have told by putting the command, we have done that. So suppose if any test you run and you have not set your data, the answers will not come. They will tell that, please tell us what is this. So the first and the foremost and the initial step is, it is xt set CID here. And this is what the actual is.
xt set CID here.
And if you look into your variable site CID, which is we had given in our panel, if you look at the data 1, 1, 1, 1, 1, 2, the firm 1, 2 to firm 2, and 3 to firm 3. So that, and over a period of time, like 2001 to 2018 or 2020 till where we have the data. Suppose your PSG data is from 1990 to 2022 or 2023. So it will take like that. Now, what if you have some values missing because what we are putting here in the software is a strongly balanced data? Now, if you have some or small values missing, you can do interpolation of the data. You can do it in Excel as well as on the stat also. So you just have a command, you can just put the values, you will get the values, you can do it. Or if you wish to, if they are the initial values, you wish to remove them, you can do that. That is your work, how you wish to go, that's your choice. Okay, fine. Should we proceed further? Okay. Now, what we are going to do, we are going to regress our variable. So we have the command reg or reg double s. You want to write, we go with reg. My dependent variable is y actual here in the data. And then we have x1 and x2 as our independent variables. Right? I just click on this and I get some result. Okay, so the regression that we are running, it is a simple OLS regression. Okay? So this here we have not thought that my data has some problem, any issue it is there. I'm considering everything to be same. And then I have just run my regression. But when I run my regression, what I do, I again say I write regress, reg. Then we have my dependent and our independent variables. You always write your dependent variable first, followed it by your independent variable. And suppose sometime what happened, we try writing it, and many times some capital in place of writing small a, I write a capital A, then it won't take it. Now suppose if I just do it instead of this x, I just write x like this, then they will tell me x2 not found. So it is always advisable that whenever you are running any regression, what you do is you try clicking on the variable list that is with you here so that it takes the actual variable. How you have written. You just click on this, you will get a regression. Is it okay? Now, if you look at this model, my R square, it is coming out to be 0.89, which we call it a 89%. And what R square is going to tell us, we'll see in our slides also. And I have my x1 as one independent variable and x2 as another independent variable. Now, suppose my y, I have just written yx. It is because I just don't want to particularly give a variable to you and later on you tell me, ma'am, the positive impact is coming and the negative impact, because this data is a sub part of my data. So I've not put the whole data for it. So the result may vary, then you will say, ma'am, why it is coming out to be negative and why not positive. So you can just assume any variable. Now suppose I assume that y is my GDP. X1, which I had one variable. Another variable was consumption. And the another variable that I had was corruption, suppose I'm writing. Okay? Or poverty also you can write. So if you look at this analysis, we are getting that X1 has a positive impact. So how do you go on to interpret that? And how do I know that it has a positive impact? Because the value, it is there 1.5. And the other X2 value is minus 1.87. So the first value, X1 variable when we see, and we look at the P value, it is 0.00. So the P value is 0.00, which is less than 0.05, which we all know that it is statistically significant. And also if sometime the P value is not there, but most of the time it's there, you can go with the T values also and you can just interpret your result based on you. That's your discretion, how you go. So we say that the variable X1, which we are assuming that consumption has a positive impact on economic growth, right? And the other variable which we have is poverty. It has a negative impact on economic growth. Now, around 89% of this model says that what are my independent variable I have taken. They explain that model is good, and this much is being explained by independent variable. Now, coming back to the slide, now this is what my pooled OLS is. Now, if we see that before I ran this analysis, I assumed few things. Okay, and what are they? Regression coefficients are same for all, whether it is firm 1, firm 2, firm 3, firm 4, because I'm not getting a different result for all the firms. If you want it, go for time series. Now, suppose you want to see firm A is better than B or B is better than C, better go for time series analysis, and time series analysis will tell you that. But here what I'm doing is I'm running a panel data analysis. That means I will get one regression coefficient at the end. If you can see, I'm talking about consumption, but it's not just a consumption of one country. It is a consumption of all the countries. So what value I have got is for all the countries. So the coefficients are same for all the countries. They are not different. Now regressions are non-stochastic. Errors not correlated with explanatory variables. I assume that my error term is not correlated with my explanatory variables. Now, what will happen if there is error term and it is correlated with my explanatory variables? Can somebody tell me what will happen? I am assuming that is why I'm running pooled OLS. If I don't assume this, running pooled OLS is difficult, right? Now, what if my error terms get correlated with my explanatory
So
variables?
why it is not correlated? The question is this. If correlated, then what will happen?
Okay, so why it is not correlated?
Not correlated.
Endogeneity.
It is a result of the if they correlated. Why this assumption is so strong? It is not correlated. By assumption, X is the deterministic variable and U is the random variable. So this random variable is not correlated with the deterministic variable X. If it is correlated, then there is an endogeneity problem. Okay, fine.
So, and the other thing that the error term that we're saying that it is greater than your sigma square value. Now, interpretation that we have done the pooled OLS regression. Now we know that the regression is statistically significant.
The last assumption.
Okay. So the assumption that we have error term and VIT term. So in the morning, did we talk about we have this panel data with us, right? And we have different forms. We have collected data. But there are some things that are not going to change. They are time invariant, or there is, they're going to remain same over a period of time. But it will have their impact on those forms, right? When we are doing this, we assume that the error term that we have here is independent of all that. So that is not going to impact. So when we are running your pooled OLS regression.
Always seeing 0 and this constant variance. I'm seeing this sign for first time.
Okay.
The typo or
I think no. This is by mistake we have.
okay. I was confused about that only.
Yeah. Now we have this regression result that we are going to do it. The value is coming out to be 89. Okay. Now the regression are statistically significant. We have seen the p-values. Now for each value, we are going to give an explanation. We are going to say that the x1 variable, which is your first independent variable, has the coefficient value is 1.5 and it is statistically significant and it has a positive relation. So you say that, or in your interpretation, you can write that a 1% change in your independent variable will bring about this much change in your dependent variable. Okay. So if my consumption, which I am just assuming that if my consumption changes and how much change it will bring on my GDP is 1.5%, or with a 1% change in that. Okay. Similarly, when you have x2 variable, we see there is a negative relation. It is statistically significant. And we say that if poverty increases, it will bring down your GDP, and it has a negative relationship with that. Now, both explanatory variables are statistically significant. It's clear from it. But we should not be so quick to accept the result because it assumes the 200 observations. So we ran the analysis, we got the result, it's fine. But then we have 200 observations here, and every firm has some different character. Okay, fine. You also got 90%, other also got 90, and all the students got 90. But can you say that their study pattern, there were some things that were different in them? That will always be there. But when we are running OLS, are we taking that things into consideration? But can it impact our result? Sure. Right? So it can impact our result. And since the panel data includes observation from different firms over time with different characteristics, the likelihood of heterogeneity exists. Now, here we come to know that there can be a problem of heterogeneity. Okay? And making POLS, if I run OLS for my analysis, it will give me biased result. If you have already read research papers or been reading research papers over a period of time, you will see that good papers before running fixed effect and random effect, they have even used pooled OLS. Okay, and also when they are running GMM, before that also they have used OLS and maximum likelihood, and then they go on to use it. So if I just rely on this and give my results as such, I may encounter a problem of heterogeneity because I'm working with panel data. Yeah. Now, individual heterogeneity or unobserved heterogeneity or unobserved form specific character, it may impact the visibility in my error term. Okay. And also, if the error term and the independent variables are correlated, we will have a problem of endogeneity. So whenever there is an error term and it is correlated with your independent variable, you have an endogeneity problem. And whenever endogeneity problem arises in our data, we try using a different model. So mostly often GMM is being used. And for the FMLS, DOLS, they can use even they use that. And also yeah, so we try to use that and try to remove the endogeneity problem from our data. Now, heterogeneity refers to unobserved unit specific character, for example, location. So there are, suppose I have collected data for 40 firms, but all firms are not from the same area. Okay, they may be from different states also, right? When they are from different states, maybe they will have some different tax paying policy or something else that is specific to that, some location barrier or any other thing that is only particular to one firm and not to another. So we can have some heterogeneity, which brings a little difference, or there's a market size, culture, maybe they are dealing with the same thing what you want to collect it, but the culture is very different. So in any way, it will impact the performance. Okay. Or we have risk appetite or managerial style for the same. Now we assume that while these characters differ across units, they are time invariant or fixed over time. That means any period of time you run the analysis, these things will not change. That time invariant. Even if you are talking about today, tomorrow, or in the future or any time, it will be same. Now, when we apply pooled OLS without accounting for these differences, we camouflage this fixed effect by assuming all units are same. So what we did is we just applied pooled OLS and we thought that everything is same and we got our results. But what we are having a problem of heterogeneity in that we know at the grassroots level things are different. There are certain things that are being infected and we are just ignoring that. So now if the error term is correlated with any of the regressors, this can result in biased and inconsistent result. You will get the result because the software will give you the result, but the result will be inconsistent and biased. And the fixed effect or random effect model, both of which accounts for unobserved heterogeneity in the panel data. Then we have to move further. Is it okay? Is it clear to you? Now, a very interesting thing that we will do is now least square dummy variable. Now they have said that, okay, fine, pooled OLS is not good. We are not going to go for it. But we are going to do is we are going to use pooled OLS, LSDV model. Now, when you're talking about LSDV model accounts for heterogeneity. We say there was a problem of heterogeneity. Now we are going to account for it. And by allowing different intercept, one for each cross-sectional units in the panel data. So we said that each firms will have a different intercept. You have firm 1, firm 2, firm 3, and firm 4. We will have different intercepts for that, and we'll try to find it out our different intercept. We'll tell like how one is different from the another and what impact the one firm is having and how it is differing. So for that will only be seen in your intercept value, right? Now difference in intercept captures the unique character of each unit that we have. Now, the term fixed effect means that although the intercept varies across unit, it is constant over time or time invariant. As a result, has no subscript. Now, if you see my beta not I have not written T. I think in the morning, Sarah also said the same thing. We have not written T because it is time invariant. Okay, that is why we are not writing T with that, with our intercept. Because we are assuming that it is 0. When we find different betas for all the different forms over a period of time, then we'll get to know that, oh, they are different. We'll do it in our practice right now. That is why here we are not writing T. That means it is same. Okay, it is time invariant. That means it is not going. Suppose there is a culture problem or there is any other thing or location thing. Suppose you have a factory in Bangalore and tomorrow you cannot just change or shift it right there. Some things are going to remain the same, the time invariant. Now, further we go with it. Yeah.
Last case. So the intercept we will have different for each firm, but we will have only one slope.
Yeah. That also we can do it like, but for that within difference we have to go. But we'll not go into that much processing of it. It is too much of a manual work. If you want difference, then go for a time series. That is the best choice. For panel, you cannot have it like that. Okay. Now comes the word dummy variable. Now, what is a dummy variable? Those who have already studied econometrics or economics may be familiar with that word. So whenever we are taking a dummy, suppose I have 10 firms. If I have to take a dummy, how many dummies I'll take for that? 9. Why 1 less?
Captured by the intercept.
Yes. So it is captured by the intercept. So that is why based on that, we'll try to do the next one. Now, this is just an example I am talking about. Suppose we have 3 firms and I am writing an equation. For that, I will take 2 dummies and that the base dummy will be assumed to be as the intercept, and based on that, we will calculate the values of the others also. So we right now we have we have 10 firms, and for that we will be taking 9. I think I've written 10 here. You please remove the 1. Because we are going to consider 1 dummy as the base dummy. Yeah, no, fine. We are correct with that. Fine. So we have here in our data, what we are going to do is we are going to take 1 intercept as your base dummy, because for that we'll take it. And then further on, we are going to go to analysis. Now we have how many firms here in firms with us? 10. So it will be n minus 1. Actually, the formula is this only. So it comes out to be 9. So now
Why n minus 1? Why not the 10 dummy can be taken?
It fall into dummy variable trap.
It means that there will be perfect multicollinearity. Yes.
Now, if you open your Excel, I've already written it. But it will be good if you make just copy the actual data and then rest of it you yourself do it in Excel. It will be good.
Can you explain about multicollinearity?
Yeah, we'll get later on that because once let's go on to the heterogeneity, then we come out to the multiple. Just in a new Excel, Hanchi.
Excuse me.
Yeah, just copy. Yeah, and make a new Excel so that we can write it ourselves. Otherwise, I've written everything.
Heterogeneity in that.
Okay, so in the panel data, usually the problem of heterogeneity is there. Otherwise, you can run HT test. So till F, you can just copy it in a new Excel. And we go on to create dummies. Okay. For form 1, we assume all the values 1 and rest of it as 0. Similarly, for form 2, all the values are 1, rest of the values are 0. Form 3, similarly, it's 1 for form 3 and rest of the values as 0. But we will only create 9 dummies. Yeah, you please create it. It will be like, no, all the values. From here, PID to Y actual, and then you yourself write T1, T2, T3.
I got it. क्या update करना है?
Update करना है.
Update करना है. Update करना है. सब नहीं ready है. Madam, they have to delete dummies. 0, 0, 0.
If you want to delete it, again we'll do it.
Okay.
So, because this this worksheet has everything done beforehand. The worksheet that I have shared, it's like done everything beforehand in it. So it's better you delete it and we'll do it together again. But we already have data in our data. It's already there. We will keep running the commands there itself. But before, like if you doing any PhD work or anything, how to do it, you just learn it here. Okay? So this dummies we are creating for our firms. Okay? So it is 1 till the first one, and then you go on to create for the rest of the values. Please do that. That is why one of the drawback when we are using this is that when you're dealing with a very large data, using this is difficult. Okay, so using this or creating dummy, it's a lot difficult. So we don't go by it. Okay, but right now you do it's a very small data set. You can go with the practice. There is the form 1. Till that you have to write 1 and 0 otherwise for all other. That is why we will get different intercepts. It's okay. These different dummies are going to give us different intercepts. Right? We are going to calculate it. We are keeping one as our base. So whatever intercept value we are doing, we are considering as our base. Based on the other values of dummies that we get, we are going to find the intercept value. Is it clear? We are going to run the regression and we are going to find the values. have, I think. Yes, yes, we do. Here we have you are considering the way to or only the first and rest is zero. Like that we have to write. Yeah, that means whatever intercept you will get is
Anything.
so different values. We are including heterogeneity. We should take that. Now, when you see that you will have different values for it, you will clear. So the one, it is only for the firm that we are. So when we are running our analysis, we will write that. Okay? Try creating dummies. So you see, I'll come back to your answer. See, we will use this. I will run this analysis using dummy. Then I will just run it with fixed effect. You will see that your coefficient values are same. There will not be much difference in your values. That will be same. So what usually people avoid going into this lengthy process, because when you have a larger data set, it's very difficult to manage it. How many dummies you will create for it, and then how many regression you will run on that.
डेटा में है इसमें कमेंट देना पड़ता है.
So the values that you are going to get is that beta naught, we have considered as a base value. You will get beta 1, beta 2, beta 3, beta 4, up to beta 9 you will get. Now we have to calculate the intercept. So how you calculate the intercept for each firm? You will write beta naught plus the dummy value that you have got. That means that is the intercept of that particular firm. Clear?
छोड़ से मारते हैं 4 महीने तक.
हाँ वो अभी भी आप बोलेंगे तो
पेपर का टाइम भी चला गया. जर्नल के लिए भी बालाजी आएगा. He wants to
Everybody has done the same. It is already there in your Excel. The Excel that I shared is the one where I have done everything. It's just that you have to now. When I run this with dummies, the command that we are going to use is regress along with I dot CID. Okay. And then you enter it. Can you see these values coming?
What you enter?
Command, ma'am. The command that you're going to use is regress by, which is your actual value, which is the value which we have not defined, actual value, your dependent and the independent variable. Then you write I dot CID. What is this CID? We have different firms, right? So based on that, we have got the different values. Now, there's certain things I want you to notice on your data. Please run it, and I hope everybody will get the same value what I have got.
ये तो वही रहेगा ना. What is it?
Everybody has done it, got the value. Now, we just go back to our OLS model that we ran. Can you please go back to the OLS simple regression model that we ran? Here the R square value is 0.89. Please come to your new model and see the R square value. Is there any difference? What it specifies? Your independent variables are, yes, sir, please.
Higher explanation.
Yeah, higher explanation. So when we ran our pooled OLS, we said that there are certain problems, the result can be biased or we can encounter certain problems with it. And then we come on to the next model, that is LSDB, and we ran and we found out. The evidence was there. When we look at the R square value, it has increased and become a little better for a lab.
Goodness of
Goodness
it.
of it. It is there.
More closer to 1.
Yes. So if you see it, the values are significant. It is negative. X1 was positive, then X2 was negative. The same thing was there. But there's an improvement. Now, before I show you the another one, how would you calculate your beta values, intercept values? There's this thing that you have to calculate. This is not as it is, this D2, D3 values is not the same because we have taken one intercept value also, which acted as the base value or the base value that we have taken. So now if I want to calculate the intercept, how I go about it, the value that I have got here, that is minus 17 plus the constant value. And then you will get the actual beta values or the values of the dummies. Are you getting what I'm telling you? Suppose we have this constant value as 78.3. No problem, we just write it here to 78.3. So now we have different dummies, right? This is my constant value that we have got. We assume now we have taken 9 dummies and the leftover one, the 10th one we said will be given by the intercept. Now I need to find out all the intercept values. So if you're thinking that minus 17, minus 13 and minus 32 is the intercept, no, this is not it. Okay, how to find it out? You will do the base one, which we have considered, plus for firm 1, firm 2, firm 3, your beta values for all of it, how you go it. The base value will remain as it, then 278.3 plus minus 17. The first one is this. Then again 278 point plus the other value.
Cumulative.
Cumulative one, you will get it. Okay. Is it clear to you all? Is it fine?
Why we are doing this, no?
To find out the values for each firm. Right? We said that there's a problem of heterogeneity. We are trying to remove it. We introduced dummy variable for that. Now we need to know what is the difference. Now, if when you go for the interpretation of the same, then from the values that you will get here, you will tell that firm A is better than this. The intercept is this. This is the lowest performing firm among the 10 firms, or this is the highest one. Based on that, you will do a comparative analysis. We said there's a heterogeneity, there's some difference in the, so that will be reflected here.
See, like if this is very small value, then we can.
Yes, suppose if you can see the 9th one and the 6th one, the form number 6 and the 9, the intercept values are very small. Okay, so you once calculate it from the intercept, then you go on to go for the interpretation of the same.
One more question.
Yes.
Dummies from form 1 to form 9.
Yeah.
Here, why not 1 to 3?
Yeah.
Is taken by the constant.
Yeah, first is replaced by the constant. Okay.
For the form 1, we will be just having 278.3, not the minus 70.
What, sir?
For the first form 1,
Yes.
it will be just this last value.
Yes.
Minus 17 will be from the form 2.
From the second one, it will come. This is for the second one. This will be given by beta 2. This will be given by beta 3, beta 4, beta 5, beta 6, beta 7, right? beta 9 and 10. This is for your form 1. Is it clear to you all? So from this, you can just tell what is the difference in these forms. Otherwise, initially when we are running the OLS, one value we were getting for intercept, there was no difference. So we were assuming that everything is same. But we said that there's a heterogeneity problem, location can vary, or culture difference, which can actually impact your dependent variable, right? Which we was ignoring in our OLS. So far, is it clear? Can I show you one more?
Just